Kids, kids who stupidly want to be involved in school and stay after and be on like student council and stuff. Man, it's so much work. Knowing that half of you were in student council. Okay. Yeah, I was really proud of my daughter. She wanted to be on her student council in school. And that's outside her comfort zone. She's a shy girl, and so, but okay, I guess I can leave early every other Tuesday to go pick you up. Not easy. Okay, so today we're talking about logarithmic functions, and logarithmic functions were created so that we could solve exponential functions. Okay, so we deal in exponential equations and functions all the time. And we needed a method that would allow us to figure out what that x is. And so we created logarithms. And so just like multiply and divide are inverse operations, they undo one another. Exponential functions and logarithmic functions are inverses of one another, and they undo one another. And so the way that I teach solving exponentials and solving logarithms always comes back to this example, okay? So when we're solving, I'm always going to come back to this. Everything goes back to exponential form. So right here, example 1 is converting the logarithmic equation into exponential form. Make sure you read the directions. But really, what we have here in letter A is a log equation. Can you guess why? It's got a log in it. Yeah, that's why. All right, so this is a log equation, and every log has its own little base. And in this case, this is base 2, and that we would read this, and it's important that you understand how to say it. We would say log base 2 of 32 equals 5. Log base 2 of 32 equals 5. Well, so my favorite phrase, you remember? My favorite phrase, and the phrase that we'll say every day. Like, I even have a story that this has spread across the nation. So, I don't know if I should tell the whole story or tell the story. So the story is, like, I've been changing diapers for the past 10 years. Okay? And so, like, you have a kid, and then your whole life is just diapers. All right, that's it. Don't have kids. Okay. So, at any rate, I started teaching again when my oldest was like 2, and I went back to work at the U of A, and then I had this sort of epiphany. So the phrase is, how do you drop a log?
Give it a swirl.
Give it a swirly. How do you drop a log? And that's the phrase, because we really can't solve equations with logs in them, okay? So how do you drop a log? You give it a swirly, and that's the key. And the swirly is the game that's spreading across the nation. Like, I had a student who was like, so, like, I totally get the swirly, that she was doing her math homework on an airplane flying home for Thanksgiving, and she came back and told me this in office hours. And she came in and she's like, I just want you to know I was doing my math homework, and I had written swirly all over my paper while she was doing her math homework. And the guy next to her is like, what's this swirly thing you're doing? And she's like, well, my crazy math teacher says, how do you drop a log? You give the swirly. And he's like, oh my God, that is the best thing ever. I'm a math teacher. I am totally using that. Like, okay, so it was really, really weird. But at any rate, so you give it a swirly. So how does the swirly work? You start with the base. you circle around the equal sign. Wherever the equal sign is, you go around it, and you pick up your power. And that gives you a base of 2 to a power of 5. And then you keep swirling around the equal sign, and that is equals the argument 32. And so this is our exponential form. And you can see that it is exponential. We have powers here. 2 to the 5th exponent equals 32. And is that a true statement? Sure it is. Okay, so that's the swirly. That's the swirly. You start with the base, circle around, pick up your power, and it equals the argument. And so we can do that for all of these to convert them to exponential form. And ladies and gentlemen, I'm always going to come back to the swirly, okay, every time. So we have log base 3 of 81 equals 4. So we're going to do the swirly. Start with the base, pick up your power, 3 to the 4th, and what does that equal? 81. There's your exponential form. So easy to do. Log base 4 of 1/16 equals -2. So again, we start with the base. We circle around. We pick up our power, 4 to the -2. And it equals the argument 1/16. Does 4 to the -2 equal 1/16? Surely it does. So the swirly, draw the little circle. It's really good. Over here, we have some special stuff. Here we have log base E. That is allowed. What is E? Not quite 3, almost 3, 2.7-ish. Good. All good things. So this is log base E of E, and it equals 1. But why? Well, we're going to convert it to exponential form. Start with the base, pick up our power, and it equals our argument of E. Does E to the 1st equal E? Sure it does. Log base E of E does, in fact, equal 1. It also has a special name. Log base E is the same as, we shortcut it, natural log. So if you see something like natural log, it has a special meaning. It could mean log base E of 2 equals 0.6931, on and on and on. So anytime you see natural log, that is logarithm natural, it's like Latin. There's a whole funny YouTube video about a log, like tree, like a log, all natural. So he's got a towel wrapped around him, like in the in the nude. It's amusing, but sorry. I don't spend all my time watching stupid math videos on YouTube. Okay. So anytime you see natural log, it's a good idea to think about it in terms of log base E. And so then you can convert it to exponential form when you can see that base. So start with the base, circle around, pick up our power, crazy power, E to the crazy 0.6931, on and on and on, equals 2. Well, I have no idea if that's true, but I can surely check that, actually. You can get pretty close. I've got an E button on my calculator, E to the 0.6931 something. Is it going to equal to exactly here? No, because I don't know what the ... is. 1.999, though, that's pretty darn close. Okay. So there's our exponential forms. The natural log of 1 equals 0. What should I do to convert this? What can I replace natural log with? Log base E. Log base E of 1 is equal to 0. So then I can give it my swirly. How do you drop a log? Give it a swirly. E to the 0 equals 1. Does E to the 0 equal 1? Yes, it does. Anything to a power of 0 equals 1. Okay. You do have the log button on your calculator. This is the common log. Your calculator uses base 10. So this button means log base 10. called the common log. And then natural log is log base E. And they're the ones we use most often, obviously. And so you can even plug into your calculator like natural log of 2, and you can see that it's 0.6931, yada, yada, yada. Okay. All right, so the swirly is how we drop a log. So example 2, convert each exponential equation into logarithmic form. So now we want to write logarithmic equations. We're in exponential form, and now we want to write an equation that has a log in it. And I'm always going to think in terms of the swirly, because I really get the swirly. But going the other way is so much harder for me. The one thing that matches is the base, however. The log base is the same as the base on our exponential, and that's really cool. So I want to write an equation. 13 squared equals 169. I'm going to convert it to a log form, which means I need a log in it. Log base what? 13. What's the argument? 169 equals 2. Yeah, equals our power. How do you know if you did it right? Give it a swirly. Sure, that's how I check, double check. 13 squared equals 169. So that gets me back to what I started with. So you can always check with the swirly, which is a really good way to do it. Here we have a base of 9. This is 9 to the 3 halves equals 27. And so I can write log base what? 9 of, what's the argument? 27 equals 3 halves. And again, you can check using the swirly. 9 to the 3 halves power equals the argument 27. So I know that I get back to what I started with. Can anyone refresh my memory what 3 halves mean? What is 9 to the 3 halves? Square root of 9 cubed. Power over index. Do you remember that? Power over index. All right. Power over index. Square root of 9 is 3. Cubed gives you that 27. Okay. Good things to remember. Oh, come on. All right, here we have 4 to the negative 3 equals 1 over 64. We have a base of 4. That's going to be log base 4 of, what's the argument? 1/64 equals negative 3. And again, so easy to give it a little swirly to double check. 4 to the negative 3 power equals 1/64. Letter D, we have e to the 4th equals 54.598. That's going to be log base e of 54.598 something or other equals 4. Is that the only way we could write it? No, what else could we use? Natural log. We could just say natural log of 54.598 yada, yada, yada equals 4. And that would be the same thing. Okay? It's important that you can go between natural log and log base e. All right. Same thing here. We have a base of e. That would be log base e of 0.1353 ... equals negative 2. What else could we say? Natural log of 0.1353 equals negative 2. Another way to write it. Anytime we see log base e, it means natural log. They're interchangeable. Okay? So easy. Any questions on those? All right. So that's just converting. And so we actually want to be able to evaluate each logarithmic expression. Evaluate means find the value. We actually want a number answer. So log base 3 of 81 equals something. How do you figure that out? What does log base 3 of 81 equal? 4. How did you get 4? Why does it equal 4? Because if you give it a swirly, it makes perfect sense. That's why, right? Okay. Because if you start with the base and circle around to pick up your power, 3 to the 4th equals 81. Okay. So how do you drop a log? Give it a swirly. All right. We have log base 1/2 of 16. Log base 1/2 of 16. And so I'm thinking to myself, 1/2 to what power would give me 16? -4. Very good. -4. The negative flips the 1/2 into 2 to the 4th, and that equals 16. All right, so -4. 1/2 to the -4 power gives me 16. All right, erase that. That's kind of weird. And again, these exponential forms are something, you know, if you weren't sure if it was 4 or -4, could you try it on your calculator? Of course you could. All right, so that's easy to do on your calculator. All right, log base 5 of 1/125. What is it? -3. Very good. Why? Because 5 to the -3 power equals 1/125. So we know we did it right. And then, ooh, tricky. Log base 27 of 3. 1/3. Very good. 1/3. Good job. Our base is larger, and we're trying to reach a smaller value. And the only way we can do that is taking roots of things. Okay, so this is 27 to the 1/3 power, which is the cube root of 27, which is 3. So anytime you have a large base and you're trying to get to a smaller argument, then you're going to use these fractional powers here. Okay? All right. Do you guys have any questions for me? So it's a 5-minute worksheet. Okay. Thank you very much.